Okay. Okay, will it echo, yeah? Yeah, I guess we can start. Okay, we're waiting for Weilian. I already pinged his father. Weilian, yeah. Weilian. Wei. Where is the turn on this thing? Okay lah, never mind lah. It's okay. Okay, so why don't you all share your screen? Actually, would StreamYard be better, yeah? Yeah, Mas Dzuizz. Would StreamYard be better or Zoom is better?
StreamYard.
You remember StreamYard, right?
Yeah, I remember StreamYard.
Maybe we should use StreamYard, yeah. Okay, let's use StreamYard. Or we try this for today. We try this for today. And it is not good, then we shift to StreamYard. Okay, we have Weilian joining. Okay, let's try. Can you each share your screen? I want to test if we can actually switch the screen separately. Okay, Dzuizz is sharing his screen. Habibie and Weilian, can we try to share your screen also? Just want to test if the screen switching works. Oh, wait, I need to change the setting. Yeah, hold on. Okay, done. Can you try to share your screen? Okay, nice.
可以玩的。但是下雨天冷了，就是穿个外套了。
这个耳机。
可以，没事。
Okay, take it away. Who is the meeting chair today?
Weilian. Today's Weilian.
All right, you're the leader of the meeting, Weilian. Take it away.
Sorry, I need some time because my computer is lagging.
Ah, no worries.
So what should we do today?
Sorry, what did you say? Oh, apparently the screen sharing that got broadcasted is always the first person who shared. Okay, then maybe let yeah. Okay, Habibie is sharing now. Maybe let me just stop. Okay. All right. So all right. So only one person can share their screen. Yeah, should be okay. Cool. So what do you guys want to do? So last week you tried solving one problem, right? And it turns out to be super hard. Do you want to try different approach today? Weilian, what do you suggest?
For the last time, the lemma's question, I was still unable to solve it yet.
Do you want to discuss it and get some hints from Dzuizz? Or do you want to continue trying it on your own?
We should take some time to discuss it first.
Oh, you want to retry that first, yeah? Okay, cool. So Dzuizz and Habibie, what do you want to do?
Habibie hasn't solved it yet. I think.
Yeah, but whether Habibie wants to try that problem or not, up to him, right?
Oh.
Habibie, what do you want to do?
Maybe try.
Lemma's problem?
Yes,
Sure. Do you need help?
maybe. I will have.
Okay, why don't you share your screen? And Dzuizz, what do you want to do? Do you want to try different problem?
Yes, I am.
Cool, cool. All right, who want to share the screen? I can help you perhaps.
I'll try sharing my screen.
Yep, go ahead.
I think maybe we can try ZooQ.
ZooQ? Are we doing ZooQ or lemmas?
Start a new question. I think we can try ZooQ. Or if you want, you continue with lemmas.
I think it's a good idea to try ZooQ, Mas Dzuizz. You have done lemmas, right? Because it's NUS December training 2021. So maybe useful for you to test.
So what do you think?
Yeah, sure. I don't know if Habibie is in it. Habibie, do you want to do Zuki or Lemas?
Maybe Zukyo.
Okay.
For this question, to simplify, it's actually to find whether there's a triplet where I, J, and K such that letter AI is bigger than AJ and letter A. Okay, let me show this. So they say there are n animals in the queue, and they say if I see both a taller animal and a shorter animal in front of me, and the taller animal is in front of the shorter animal, then you output 7 years of misfortune. Yeah.
And H is a permutation of 1 until n. Yeah, that I think that will be important.
The hard part over here is that I only have 0.5 seconds.
I think we should start like subtask by subtask first. Maybe for subtask 1, we can brute force all the triplets. Right, for subtask 1, because n is smaller than or equal to 400.
In that case, you can literally use brute force for the first question. And I saw both 1 and 2. Okay. Let me see. Yep. This one. You see, I use scans to speed up even more. But still, there are some TLEs.
Oh, but then what is the method though?
Excuse me?
How do we do this? Did you brute force?
Yeah, this is for brute force.
Oh, that's brute force. Okay.
So yeah, if you use brute force, it is
Weilian.
possible to solve the last 2 questions. Yeah. Any ideas? This is brute force.
Maybe maybe we can look through the array. We can look through the array, take note of the tallest animal that we have found so far in the queue. And yeah, and also we take note of the previous number. No, previous number. If it's greater than the previous number but smaller than the greatest number so far, then it's 7 years of misfortune. If not, we just continue. If it increases until it is greater than the largest number, then we set the new largest number as the current number. If it is greater than the largest number but then decrease again. Oh, yeah, let me try that. Let me try looping through the array.
Okay.
Do you have any other methods? Do you have any other?
Speeding up, like I put here, like if the current number is smaller than the largest number, just skip the whole round. Yeah.
Oh,
Because it must be bigger in order for it to possibly work, right? Possibly be 7 years of misfortune.
So, Weilian, you are able to solve, but time limit exceeded, yeah?
With brute force.
Oh, this is brute force solution. Okay.
Brute
Let
force
me
is
try
a
the
little
other one.
bit of improvement, I guess. Because if I use pure brute force, it's TLE for the second question also.
Oh. Oh, okay.
You see, for this one, it's pure brute force. Yeah, it's like no optimization at all. The second question is also TLE. Anyway, it didn't help much.
Yeah. If current smaller than max or equal to it. Is it strictly taller than? It is strictly taller than, right? Yeah. So current smaller than current max, index in plus plus. Uh, 7 years of misfortune. Hmm. Zero.
Any good idea except for brute force?
Oh yeah. Like I said, I wanna try if I can look through the array, and I take note of the current maximum element, the current greatest animal, and the previous height. Yeah, I wanna see if it works. I need.
I think for all the test cases to pass, it should be at most 2 loops. Yeah. 3 loops should be TLE.
Can this be solved with dynamic programming?
Dynamic programming,
I don't think it's a dynamic programming.
yeah. Is it really dynamic? Doesn't seem like dynamic programming to me. I don't see the dynamic programming. Oh. Seven, 1, 10. And current smaller than current max. 5, 6, 8.
Wait, I think I kind of get the idea.
3,
So
7, 9.
then we look through the queue to find the first one, which is the tallest out of the triplets, which is A. And we will find the smallest element right after it. So I think you can save some time to get B, right? Because B should be the shortest. And C, we should use C as the second smallest element. And just C, if C is smaller than A, then there is 7 years of misfortune. Otherwise, it's sound and like for this round, it's sound and safe. I think that would be like yeah.
Oh, how about that? Safe and sound. 7 years of misfortune. I wonder what kind of superstition this is. Submit. Oh. 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 Oh.
Oh, N is up to 2 million.
My submission, my most recent submission, it got wrong answer, but the first TLEs appear at subtask 4.
How much of task 3?
Subtask 3 is wrong answer.
But why do you get wrong answer?
I don't know. I can share my screen to share with you the code.
But it's still possible that for those test cases it should be sound and safe, but you just put 7 years of misfortune and it just returns 0. So it might not have calculated actually correctly.
Wrong answer. If there is, wait, what? I see both a taller animal and a shorter animal compared to me in front of me. Does that mean that if there is a taller animal in front, directly in front of animal I, does that mean that animal I's vision is blocked and then it can't see the animals behind and the animal I -1? Is it like that? Or when they mean see, it's as if the animal can see everything in front of him, all the animals in front of him, and then he can see, yeah, see.
No, he can see everything.
Oh, he can see everything.
I used the brute force to test it.
Oh, he can see everything. Then we don't need current. We need current mean. Oh, wait.
We also need to make sure that curve min should be behind curve max.
Yeah. How do we- Yeah, how do we make sure that the shorter animal is behind the larger animal?
Maybe save the index.
Save the index. Save the index. Wait. But why should we save the index?
But maybe saving the index. Maybe the maximum before have a lower index maybe. Save the index.
What if we have the prefix max? Does that help? No. End of save the index. If current greater than
I think I realized something.
yeah.
Let's say A be the tallest one, which is also the most front one among the triplets. The sequence right behind A should always be not increasing unless the number is greater or equals to A.
Yeah, but then if when you say like that, then that means that the animal's eye animal eye's vision is blocked by the tallest animal in front of him. Right?
No, there is no need to talk about block vision because you see the mathematical definition in the problem. There exist a triplet
There's no
ABC
blockage anyway.
Oh,
such that A is in front of B, in front of C, meaning anywhere in front of B and anywhere in front of C, while the height, the tallest is A and the shortest is C. So, sorry, the shortest is C.
no, yeah.
Actually, it's a V. If you draw it, it's a V. Basically, is there a V? Is there a V in the whole sequence?
Yeah, so that means so after the maximum point, it has to be decreasing. Then it increase higher than the maximum point or equal to,
Correct.
then it decreases. Increase higher or equal to, then decreases again. That is what mine did. That's what my code did, but it has wrong answer in subtask 1 also.
Okay, explain your code.
My code, I look through the input with a I take note of the previous height and the maximum height up until that point. So first I get the first animal's height. Then to input the rest of the animals, this is the current animal's height. If the current animal's height is greater than the previous animal's height, and the current animal's height is smaller than the current max height.
Wait. Why is the current greater than previous? Previous in this case is in front of the queue, right? Because the list is starting from the front, right?
It's starting from the front. It's looking to the front, right? 1A, B, C.
A is smaller here, but if you see the height definition, A is the tallest, which means A is in front of, in this case is C, right?
Oh.
Yeah, so you got it reverse, yeah? Try to fix your code.
Parent equals to 0, even minus 1. Or in I equals to n minus 2, I greater than or equals to 0, I minus 1. This. If AI greater than 5 minutes. Oh wait, I can just copy this. Yeah. Oh. Mm. Ten. So it's at the end. It's at the start. So since one is great. Seven. Right. Wait. 9. So it's at 9. 9 is greater than 1. Oh wait, it can't be.
Oh, maybe the input, just input format, type it manually, maybe copy paste ruins the input.
No, don't think so. 5, 4, 6, 3, 2, 8, 7, 9, 2, 8, 7, 9, 10. Still, if A is at the front of the
What-
queue,
Where is pref and where is Carmex? Can you print pref and Carmex also?
Ref is 1, Carmex is 10. It is currently at 9, looking at 1 and 10.
No, it's currently at 1. Wait.
It should look to the front.
Wait, you are looking from the front, right?
Yeah,
I'm confused.
I
Are you
am.
looking from the front or are you looking from the back?
I'm looking from the back. Because the front was wrong.
You're looking from the back,
They're not
which means previous should be the smallest, right? Then it's not current max that you're looking for. I'm confused. So current max need to be in front, no? So you need to look from the front. Current max is the one in front, right?
Yeah.
Yeah. So you need to look from 0 actually.
Isn't that what I did just
From
now?
1.
Is that not what I did just now at the start? I don't understand what.
Okay, try to fix it from 1 to yeah.
This passed and this is. Oh. This will be the same as. What's the difference? Yeah, it's the same.
You got wrong answer, yeah.
Isn't.
That is
Oh, but it's
curious.
wrong answer. It's not TLE. Oh no. Why is it wrong?
Okay, that is quite curious. Can we go back to your logic again? Can we go back to your code? So you are tracking the maximum. No, I think you also need to track the minimum, Mas Dzuizz, because it doesn't have to be always previous. Previous is right in front of your current, right?
Yeah.
But it doesn't have to be right in front of you. The guy that is shorter than you can be anywhere between the tallest and yourself.
Yes, and that was the problem we were facing just now. How do we how do we check through all of the maximum and minimum to find out one that is suitable for AI that while still not getting clearly? Right. This is
Okay, I think why don't you do this way? Define a safe range. So as you look from the front of the queue to the back, the safe range changes, right? So let's say scroll down to the test case one. Yeah. Okay, so at start you have 5 and 4. That means the safe numbers are okay, maybe let's not use that example. Yeah. The 7 years of misfortune in the sample 2 is which one? Yeah. 5, 3, 1. No, 5. It's actually oh 10, 1, 9. Yeah. 10, 1, 9. Yeah, this looks like imagine if you have a Boolean array of size n. I think you can have, right? 2 million is okay, right? Boolean should be sufficient, right?
yeah.
So you define safe and unsafe. Yeah. So let's say it's a safe array. So everything is safe in the beginning. When you see, let's say 10 and 1, then you know after this you cannot get any number between 10 and 1, because any number between 10 and 1 will make it 7 years of misfortune, right?
Yeah.
So that range becomes unsafe.
Yeah.
Yeah, so this feels like a range update, no? Range update point query.
I don't understand.
Okay, guys, I'll say something. This question can only be solved if your program has only one loop, at most one loop. Because I tried 2 loops and still it's a TLE.
What?
Well, it's not about the number of loops, but it's about the time complexity, right? So this is 2 million. I think you can still pass with ON log n complexity, because ON log n will give you about, yeah, maybe 20 million calculation.
O log n
Oh,
is
yeah, 40. Yeah, Habibie?
O n log n is sorting and binary search, maybe, right?
Yeah, but data structures like segment tree, Fenwick tree, sparse table are also ON log n. Oh no, sorry, not sparse table. I think. Yeah, sparse table also. But in this case, I believe this is a range update point query problem. So imagine you have a set of safe ranges and unsafe ranges, yeah. And then every time you see new number, you have to update, because some number becomes unsafe. So just like when you meet the, let's say 7 and 1, then from 2 until 6 is unsafe. If after 7 and 1 you see any number between 2 and 6, then it's 7 years of misfortune already. So it's a range update, but it's a point query. Are you guys familiar with range update point query? Have you learned any Fenwick tree, segment tree? This is my guess. Yeah, I don't know. We will need to check.
I understand a little.
Yeah, but then when we wait, so this
Maybe some data structure, so like stack maybe, so we can add, but we can remove it from the top easily.
Yeah, maybe good idea. Explain the logic.
Actually, I still doesn't understand how what condition is to remove that. But maybe we can use stack data structures, because when we want to enter it, it's come from the top. But when we want to pop it, it's come from the top too.
Sorry, can you repeat again, Habibie? When you
The stack data structure. So is when we push, we add the element to the top, and then when we pop, we remove the element from the top. So sounds maybe similar.
so let's say we process the queue from the top, put it into the stack. In what situation will it becomes misfortune? That means we have a large, a tall animal, right? A tall animal followed by
A smaller animal.
followed by some animal in the middle, right? But how do we know? How do we know? Oh, yeah, makes sense. Makes sense. You basically keep the tallest animal at the top of the stack, right?
Yes.
Yeah, makes sense. Makes sense. I think that's a good idea. Try it, Habibie. It sounds like a solution. Maybe I should try also. Let me try.
I don't understand.
Okay, so Mas Dzuizz, the idea is, imagine you have a stack, and then you put the animal height one by one into the stack.
Yeah.
For something to become misfortune, that means the top of the stack, or rather, there's some tall animal that's already entered the stack first, followed by shortest animal, followed by the medium animal, right?
Yep.
So imagine if you keep the tallest animal at the top of the stack. So if you get animal that is not taller than that, then you sort of can ignore, right? Because you already have someone taller than that, right?
Yeah.
Yeah. Yeah.
But then, like,
yeah, and then you keep track of maybe two other pointers, two other sentinels, right? I'm getting confused as well.
But actually, we keep the tallest animal in the back of the stack, right? So we push the taller animal and then a lower animal. So the tallest animal keeps in the bottom of the stack.
So then what happens when we push a new animal? What would you do?
So maybe Mas Dzuizz try to approach this problem subtask by subtask because you haven't even achieved partial point.
Brute force does subtask 1 and 2. We know that already.
Yeah, implement it first. I mean, at least you get a partial point. Remember, you need to do it. Let's practice that subtask by subtask approach. Yeah.
Okay. So brute force is checking all the triplets, right? For in I equals 0, I smaller than n, I plus plus. For in j equals 0, j smaller than n, j plus plus. For in k equals 0, k smaller than n, k plus plus. This is
Okay,
the
this is O n cube. Yeah.
will work for subtask 1.
Yeah, only subtask 1, I think.
If
Yes.
I
Okay. Go ahead. Yeah.
equal j or j equal k or I equal k, continue. A, B, C. If AI if AI if AI is greater than a k, right? Yeah, if AI is greater than a k and a k is greater than a j, then we see out 7 years of misfortune. Oh. Zero 3 1 0 3 1.
Yeah, your loop shouldn't all start from
Oh.
1. You lose the sequencing.
If like this, I plus 1, j plus 1. So this is not necessary. Yeah, it's not necessary. This is unoptimized brute force.
This is gonna be a TLE, I know. This is why I tried.
Yeah, but at least you got a partial score for subtask 1. So that's the idea. Now we solve subtask by subtask.
For brute force, you can
TLE, right?
optimize it until you got the second one also. So you can earn another 50 marks.
Yeah, I honestly think this is a range update point query problem. At least I believe it can be solved that way. Mastish, do you want to try that?
I
You want
still
to try my idea?
I still don't understand your idea.
Okay, let me
Point update.
explain my idea. How do I do that?
Whiteboard.
Okay. Hold on, yeah. Let me open up my VS Code. Open a new file. Okay. Yeah. So what I mean by range update is like this, right? So let's say test case 1. What are the numbers for test case 1?
Oh, I get it. The
5,
step.
4, 5, 4, 6, 3, 2, 8, 7, 9, 1, 10.
5, 4, 6, 3, 2, 8,
8,
7,
9, 1, 10.
9, 1, 10, right? Okay. So we have 10, right? N is equal to 10.
Yep.
So let's say this is a safe array. Safe array. So in the beginning, everything is safe. Okay, how many is this? 3, 3, yeah, okay. In the beginning, everything is safe. And then we see 5, right? We see 5, okay. This is only the first animal, so everyone is still safe. Right, and then we see 4.
Wait,
We saw 4 and we saw 5 first and then 4. So anything between 5 and 4 is unsafe. But between 5 and 4, there's nothing. So that means everything is still safe, right? And then now we see 6. Because we see 6, is there anything taller than 6? No, nothing ahead. So everything is still safe. Now 6 is the tallest we see so far, right? Then we saw 3. So after 6, we saw 3. That means between 6 and 3 is unsafe, correct?
Yep.
What is between 6 and 3?
Oh, 4 and 5.
Between 6 and 3 is what?
4 and 5.
4 and 5, right?
Yep.
So 1, 2, 3,
Oh,
4,
see.
5. They are unsafe. They're unsafe.
Oh.
Now you see 2. All right, 2, and you have keep track, right? Your maximum, your current max is 6. So anything between 2 and 6 is now unsafe. So that means you make an update, right? Now, and then you continue, you see 8. All right, 8 is the maximum so far you see. You update current maximum. And then you see 7. Okay, between 7 and 8 becomes unsafe, but doesn't matter. Right? And then you see 9. Okay, now 9 becomes the maximum. And then you see 1. Oh, wow. Now everything between 1 and 9 is unsafe.
Yep.
Which is what? 2, everything. Yeah. So like that, right? And finally, you see 10. Right? And then, well, 10 is safe. Right? You see, so when you check for 5, 5 was safe. This one, right? So it's okay. This is okay. This is okay. And then when you check for 4, yeah, 4 was okay, also okay, safe, right? And so on. And finally, you inserted 10, right? 10 was safe. Right? Okay. Now let's try the second test case, right, where it fails. It's a 7 years of misfortune. This one, right? Now the safe array, same thing. We start from how many days? Yeah. Right. So we see 5, we see 4. So everything is still safe after we see 5 and then we see 4. Now between 4 and 5, also everything is still safe. And then we see 6. So we update the maximum is now 6. And then we see 3. Okay, between 3 and 6 is now unsafe. So 4, 5. Right?
Yeah.
And then yeah. And so on. Basically 6, 3, 3, 2. Okay, 6 and 2. So anything between 6 and 2 becomes unsafe. 1, 2, sorry, 6 and 2, 3, 4, 5. Okay, 6. Right, and then 8, the new maximum. 7, between 8 and 7 is nothing. And then 10 is the new maximum. And then wow, 1, 10 and 1. That's like everything becomes unsafe, right?
Almost
Everything between 10 and 1 becomes unsafe. And then now you check for 9. The last item is you check for 9 and you found that 9 is unsafe. Boom! 7 years of misfortune.
Okay, now
You see, that's why I said it's the range update point query problem, which you can use segment 3.
oh my god.
Can you use Fenwick 3 for yeah, I think you can use Fenwick 3, right? Yes, you can use Fenwick 3.
Chemistry can only be used for sums, not for maximum and minimum.
Fenwick 3.
Well, technically, because it's only 0 and 1, you can deduce it also, right? You can treat it as sum. Yeah, but anyway, Fenwick 3 is a bit complicated to do range update, I think.
I finally
Yeah.
understand the stack approach.
Oh, okay. Explain, Habibie. You want to share your screen?
Yes, maybe
Are you reading the editorial?
There's an editorial?
for the approach, but I doesn't understand for the how the editorial explain how to create a stack.
Yeah, so Habibie read the editorial.
Oh my god, there's an editor.
You want to explain? It's like spoiler though.
So
But it's okay. If you understand it, maybe Habibie, you explain.
so firstly we add 5. 5 is the tallest, right? And then we add 4. 4 is smaller than 5. So for the next push, we check if it is in the range of 5 and 4. We return false. So, but it's 6. 6 is the tallest, right? If 6 is the tallest, we don't need the 4 and 5 because here A has to be the greatest, kan?
Yeah.
So 4 and 5 cannot be. So 6 is the tallest, and then we push 3. 3 is in. So we check again, kan? After the push, is it in the range of 6 and 3? Wait a minute. Oh yeah, but it's true. So we keep it. The one that I doesn't understand is when we have 2 in our stack, but actually it's the queue, maybe not a stack, because in the before operation we pop it from the back, so maybe it's a queue. And then when we add 8, the top 8 is greater than 6, right? So we change the tallest to 8. We change the tallest to 8, and then we pop all the elements before 8. And then 7 is still in safe zone, so And then we check again, kan? 9. 9 is greater than 8, so we pop it. Finally, 1. 1 would
Jadi maksudnya dari 4 sampai 40 disusun yang terdiri dari 10 angka beda yang sama.
oh, and then we push 1. 1 is smaller than 9, so we keep it. But when at 10,
5, 10, 15,
it all gets
20,
destroyed.
30.
So there's no return false in the condition. Maybe we can continue to the
Yeah, I actually
next
not sure if I understand. Habibie, why don't you try to implement the editorial approach with stack and see if you got it correct. Mas Dzuizz, do you want to try the segment 3?
Yes, I am.
You want to share your screen?
Okay.
Because actually reading editorial is good for learning, but perhaps it's better to try it first on your own, right? Yeah, actually, since it is sort of spoiler already, so I was reading the editorial also just now, and basically nobody in that NUSH qualification round, nobody came up with a stack solution. But it was designed that way by the problem setter. It's an intended solution,
Wow.
right? It's an ON, very clever ON solution. That's why I think the half second limit, because they wanna push for ON or very low ON log n. Most people who solve all the subtasks, they use ON log n. So the editorial actually gives a spoiler in that sense. Yeah, so since Mas Dzuizz, you're already starting the segment 3, is an ON log n solution to the range update point query. Why don't you try and finish it and see if it's not TLE. Habibie, since you already read the stack solution, maybe you can implement it and see if it works.
Wait. What exactly are we trying to find in the segment 3?
So it's, yeah, basically remember that it's a range update point query problem,
Yeah. That's not.
and your range is a Boolean safe range. It's not even point query. Yeah, it is point query. Sorry, range update point query.
It's not some.
How do you update range? Do you know how to do range update?
Lazy propagation. I've done it once, never after that. I'm not good at it.
Okay.
Forgotten how to do it. I have not trained enough on it. No, it's not plus. If we just want boolean, yeah, then this doesn't really matter. We can just wait. Range update point query.
Yeah.
Oh, yeah, we don't care what the like, yeah, we can just use minimum. Doesn't really matter. It's the query that matters more. In index, in L, in R, in point query. So in X, in
Just what
if no.
why
If
would you need you there? You're not updating, right? You're just querying.
in index, in L, in R, in X, if L equals to R, then we return L. Oh yeah, but if that, then we return segment 3 index. If not, then we get mid equals to that. If okay, never mind. Else that Yeah. This is that. No, this is not supposed to be. If x smaller than that, because we don't really need the minimum, we can just, we want the exact number, so we just need query index. Yeah. Yes. Then
How about the range update? How do you range
the
update?
range update, this is where lazy propagation is needed. Wait. Update. Lazy propagation. How do we do lazy
Here in this case, you will always update it to be unsafe, right? That's why you don't pass any value.
You'll always update it to be unsafe. That's why you do, yeah.
Okay.
Um, update. Oh no.
Okay. Even though it's void, you can still return number. Yeah. Okay.
Yeah, just it as if it's not returning anything. If L equals to R, then we return segment 3 index equals to 0. I don't think we can do lazy propagation with this unless we find an actual function that we can use. Maybe
Can
counting.
segment 3 do range update?
Oh yeah, segment 3 can do range update. But then the problem here is that we just want a specific point, right? So when we have the safe array like 11000110, right? Then we want to update this area, for example. We
Usually,
oh,
can it be just prefix sum? Yeah.
yeah, we can just set everything to 1. Then if wait. Yeah, so everything is 1 if L equals to R, or if what did I do just now? What is, yeah, if then, yeah, then segment 3, we want the point if L equals to R, or if the current segment is equal to 0. Yeah, if segment 3 index, oh, why is the AI so smart? In it, if, yeah, I think we should work. Oh, I don't know why there aren't squiggly lines. You can just, okay, never mind.
I think lazy propagation also means that when you do query, you need to cascade all the way down, right?
Yeah. Yeah, but then in this case, we don't really need to cascade all the way down, because when something is unsafe, it will always be unsafe. There's no way it can become safe again.
Yeah.
It's not plus, it is return segment 3 equals to max of 1 3 plus. Yeah. You can
Plus.
no, I'm not
Plus
even.
would mean
Yeah. So one segment of the segment 3, if it's equal to 0, then that means every element inside that segment is unsafe. That's what I'm trying to do here. So if the two segments inside that segment, if one of them is true, or yeah, if at least one of them is true, then this segment is also true. This segment is also safe if at least one of the two segments
but
inside it.
the number can be more than 1. Yeah. If you are using max 1, it will always be more than 1. It will always be true.
Yeah.
Oh, you're using sum, is it?
Yes.
Oh, I see. So, okay, you are actually doing segment 3 sum. Okay. Okay. All right. Continue on. Sorry. Okay.
In I equals 0, I smaller than n, I plus plus, we need the max. In current max equals to V0. If, okay, that will be later. If,
Yeah, I understand.
this is the current array, so, oh, wait, then what's the, oh yeah. If, query 1, 0, n minus 1, if query is equal to 0, see out 7 years of misfortune, return 0. If it's not, then what do you check now? Seven years of misfortune. If query of that is 0. Then if it's not, then we just update it into the array, right? Oh yeah, then we update 1, 0, n minus 1, I, no, min of I, no, min of vi and current max vi current max. Yeah. Yeah, things like this. So update this.
It's one index, yeah.
It's one index. What is?
It doesn't matter, yeah. No, it's one index. It's one until n, the numbers.
Oh, that's the height, right? I don't think the height will matter. Will it matter? Oh yeah, it will matter. Oh, it would matter.
You are actually doing the height, right? Your safe array is the array of height.
Oh, yeah, then it would matter. So we can just reduce the height by 1.
Yes.
Vi minus.
Yeah. So you need to build the segment 3 first, right?
Yeah,
if you build
it's
the
one.
segment 3 will be okay. Have you implement build?
You just need to set
You
everything.
need to build it first, no?
Yeah.
Or you don't need to, is it?
Building is yeah.
No,
If you already building is when you already have the array beforehand and then you put it into the segment 3. That
yeah, but you already have the array beforehand, which is everything one. You need to build that, right?
yes. So I set everything in segment 3 to 1, right? Or
No, right. Segment 3, you need to build it because it's not just everything one. It will be like n and then half of n, right? Quarter of n, quarter of n, quarter of n, quarter of n, right? That's how your segment 3 will look like, no?
oh, and oh yeah.
Yeah, good. So Yeah, and I think you will need to change your query, but let's try this first.
Oh, use 1, 0, and minus 1. Query.
Yeah.
Query.
So you need to change your query because okay, in X is the height, right? So in X is the actual index. So I think if you find it to be, hold on, if you find it to be, how do you know it's unsafe? You know it is unsafe when
I thought if segment 3 index equals 0, return 0.
Almost accepted.
Oh,
you got it accepted, Habibie?
Not yet.
Oh, no, yeah. Okay.
yeah. Why is this wrong? It's 4. 4. 4, 1, 2, 3, 4. 2. Is that 2? 2. 2 should not be a problem. It is not.
Hey, your query is not I, no? Your query should be the height, no?
Oh. Oh, but still wrong. I is 6 now. 0 and 6.
Yeah, the height is 6 now.
No, I is 6. So it's this.
Oh, you see out I. Okay. Yeah. So, all right. So now, explain the logic first. You have the original array to be everything 1, right? And you're building a segment tree of sum of everything 1.
Yes.
And you need to do range update, right?
Yes.
And your range update is basically, let's check your update. If L to R is within X to Y, if L to R is within X to Y, you will update everything to 0. Correct. You will update everything to 0, but you did not propagate it, yeah?
Yep.
Yeah. So that's actually the problem, right? Because if you query a point, that's why I said,
How I don't understand how that is a problem. For example, like let's say this is the segment right now, right? If everything inside it is 0, then if everything is inside it is 0, then we will when we want to find something like over here, for example, we will eventually get to this segment.
because you added line 27, yeah, basically, yeah? You're
Yeah.
saying in your query because you added line 27, it will be immediately 0.
Yeah.
Okay.
Yeah.
And if you are in 1 point, you will return it. Okay, fair enough. Yeah. Fair enough. Makes sense. Okay, let's check your individual build, your call. Let's check your individual calls. Scroll down to your main. So you're querying 1, 0 until n minus 1. Vi, okay. Your update is 0 until minus 1. Oh, you never set CarMax. You never keep track of CarMax.
Oh.
Yeah. Also, yeah. Actually, you're looping. Should you start from 0? Because you already have T0, right?
Oh yeah. Oh, but doesn't really matter because
Okay, now
it will be the same.
yeah, let's check now where is wrong. Where do you get it wrong? So where do you return 7 years of misfortune? Can you see out I and Vi?
6. 6. 6 is
So it's still the same thing. But why is it returning 0? You want to print out your whole
segment 3.
segment 3 here? I think you need to see out. Okay, anyway.
I have to see out query.
See out I and VI, and then see out I and VI, and then see out the whole segment 3.
See out I and V. Oh, see out I and V. And then see out the whole section. I can do this for this. For in J equals 0, J smaller than or equal to 4 times N. J smaller than 4 times N. J plus plus. See out segment 3. Okay. Oh.
Okay, so y is 7. Oh, sorry, 6, yeah? How come it's 6,6? How come I is 6? But, oh, yeah, of course. 7 minus, yeah. Okay, so 6, right? So if we follow the logic of query, 6, where does it go to?
It would be
X3, and then
1. Then
do you want to just see out in query, mas? If no, leave it, leave that. Yeah, go to your query. Yeah, over here, just heck like if X is equal to 6, you know, because your failure is in X6, right? Just see out. Yeah. See out what you need to see out here. Yeah.
093592. 0930 until 9. That's the whole thing. 3. Segment 3 index is 3. Yeah, that's correct. Then 592.
You return at 592, yeah. Why do you stop at 592?
Oh, because this is after the return. So if I do it before the return, the last one will be the one giving the return. Yeah, so 570 is the one that caused the error. I mean, is the one that return one of these.
Yeah, but is 570 correct? Why
5.
did we update 570? Why did we update it to 0, right? When we reached that 57. Yeah, maybe you see out in your update. See out in your update when you actually update to 0. You see out first. When do you update to 0? Only on the first line, right?
Yep.
Yeah. Instead of doing that,
Yep.
you see out to no see out. Yeah, okay.
Yeah.
XY. You also need XY.
XY. That is a lot. 3 4 3 4 4 4 4 5. XY has to be 57, yeah? 57.
Why do you do that?
It is not inclusive.
What do you mean it's not inclusive?
Update should not be inclusive, right?
Oh yes, update should not be inclusive. Correct.
Main plus 1.
So yeah. Yes.
So that means for
And you
update,
need to handle when the range is crossing each other. So when if L is less than R, you need to return. You need to.
yeah.
Okay, try first.
Oh, it's all safe and sound. Oh no, that is not the right thing. Oh, yeah.
Remove it, yeah, remove it.
X greater than 1. Seven sound. 7 is a subject. I still feel like there's something missing.
You added space. You miss some C autos, I think. Yeah, this one. Yeah.
It's still wrong.
Why do you add x greater than or equal y again? Explain.
Because well, that current max and VI may have a difference of 1. And when that happens, they overlap.
Okay, but it's in update, right? Well, I think you edited query just now, not update.
No, I did it. Yeah, I did
Oh,
it.
yeah. Oh, update. Hold on, I don't understand. Why do you return sec3 index for update?
To sum up for sum. Oh,
Oh, because it's sum, yeah. No, then you shouldn't, right? If x greater than or equal to y, you should just return 0 because it's invalid.
oh,
Oh, yeah, and you have to return 0, right? Because it's invalid. And I think you need to do it first. The first check. No, you are not updating anything. What are you doing?
what do you mean?
It's invalid case. When x and y cross each other, it's invalid case. You
Yeah.
just return 0.
Oh, because it's on.
It's
Yeah.
invalid. If you add in the second line, then you are actually updating the whole thing incorrectly.
Return 0. Yep.
Yeah, this should be okay. Try again. Did you even paste?
Yep.
You didn't even paste. Did you?
Yep.
Okay. Yeah. Okay, now what is the problem? Now it's harder because you passed the test case. And we don't know what went wrong.
I think we can just put the x and y variable in VI max. This will make it easier. And then we can manually check it here. If x1 variable one.
I see.
But if it's yeah. Oh, yeah. Wait. Yeah, it should be greater than not small, greater than equal to 1. Yeah. If x smaller than or equal to, so that means we don't need this. What was it? Like that. Oh, do we need it? If x smaller than or equal to y, that means x won't be greater than y.
What did you change just now? What did you remove just now? The last thing.
The if x greater than y. Wait, it has to be greater than or equal to.
Oh, that's interesting. How is that possible? What is xy? How do you change xy?
X and y is the range that you want to change to 0. Inclusive.
Oh yeah, it's possible, right? Because let's say 3 and 5, then it will be 4 and 4 only.
Yeah.
Yeah, so it's possible to be equal, but when it is equal, then you have to update. You have to actually update.
Yeah. Then that shouldn't be a line, right? Because I already changed the value.
Yeah.
Smaller than or equal to y.
Correct. Okay, good. Now let's debug. Yeah, see out like just now. See out where you fail.
Why did I delete them?
Don't change the line. I mean, if you change the line, then you cannot comment, right? Just create new line. Later you can just comment and you don't lose all the debugging.
Yeah. Vi. Then we can also check the query. C out L R X.
Yeah. Okay, let's try.
It's still 6.
6 again, same place.
093 over 3343 095 595 575 565 092 over 2 022 091 041 021 011 097 597 577 096 596.
Yeah. Weilian always starts with a hard problem, yeah, and we end up spending the whole 1 hour and a half trying to solve a hard problem. Maybe next time let's not try it this way. Yeah. It's a bit too much.
The next session, Habibie
I wanted to avoid this situation like last week. Yeah, we end up trapped in that again.
I also didn't expect that it's gonna be like so hard.
Yeah, like
It looks some easy, but the time limit is the most important thing here. The time limit is what like kills us every time.
yeah. Well, actually, in a way, yeah, we may not know whether it's easy or difficult. That's also true. There is editorial also. Anyway, it's okay. We got unlucky again, I guess. Choosing the wrong problem again. It's okay. So okay, let's debug this and figure out. Yeah, Mastis, what happened? Why is your query returning 7 years of misfortune? Five, 6, 6. What is that? 5, 6, 6 again? Remind me again. Query means
LRX.
Oh, LR. Okay, and 6 is fully within LNR.
Yeah. So it should be. Oh, let's print the secretary index also. One. It's one.
Why is the last one? Why is the last one is not printed? Yeah, the last query 5, 6, 6 is not the last query, right? 5, 6, 6 is not the last query, right?
Ordering. Where is it? Okay. Okay, now it was 6660 is the last query. So
Yeah, why is it 0? Now we need to check why in your update. If x is equal to 0, you debug, yeah, in update.
So now we do this in update. We just have to copy this. Where's update? Here. Okay, any updates? LRX.
So when x is 6, yeah. No. Oh, when
LRXY.
Yeah, any update that contains 6 in between. Yeah.
No 6. No 6. X and Y should have 6 somewhere in between. Yeah.
Just now 6 6.
6 6 6.
This 6 6. What is that? 0966. Why is it 0966?
This is the third group of update. What? When do you do update? When query is 1.
What is your CarMax? Can you print CarMax also in your query update debug? No, okay, here can. Here first, yeah. Here is okay. Just see out there. Just now, it's okay. Just want to see what is the CarMax at that time. As a point of error, yeah.
Seven.
7.
That was 8.
Oh, that means it's 8, right?
8, yeah.
Yeah, of course. Okay. So the value is 8. But what is the range you are trying to update there? When you do update, okay, that means the update is before, right? No, I don't get it. You fail. Oh, you fail when it. Yeah, of course, like CarMax is sorry. Never mind. So go to the update and print the CarMax also. Oh, you cannot, yeah. You won't know, yeah. At the point of update.
I can if I want.
Oh, you can print it here on line 57. No, just print it in line 57. No. Okay, yeah. You can also do it that way. But yeah. Yeah. Use a different symbol maybe so that we know it's CarMax. Just say CarMax.
We know CarMax is the only one after this, and this is for update.
Okay. Yeah. Can.
Wait. CarMax first was
When did you make that update to 6?
5.
Yeah, that one. CarMax is 5.
Oh.
Why are you updating 6 and 6 if it is 5? Minimum VI. Why is it minimum VI and CarMax?
Because the range you want to make it unsafe is VI until CarMax, right? So it means
VI until CarMax. Okay, but +1. Okay, got it. But what is VI in this case?
the height.
Which is what value now?
And
Can you see out there also? Yeah, see out in this line 58. Just at the yeah.
to 5. 5.
Let's go. Yeah. That one, right? 7 5.
This is before the
Which
query.
means 6. Yeah, so current max is 7. Yeah, correct, right? Current max is 7. And why is it 5 then? Why is VI 5 then? VI should be 6, no? See out I also? Can you see out I? Yeah, we also need to know VI, by the way.
Seven 5 5.
So I is 5, which means it is the 6th which is 8, right? Oh, current max. Oh, yeah, that's the problem. When you see a larger number, you just update current max. You don't do update. That's the problem with your logic here. So
Oh,
you see your current max so far, when you process 8, right? Your current max so far is 5. Sorry, 6,
yeah.
right? When you process 8, you should just ignore it. You shouldn't update 6 to 8. Yeah. Yeah. Yes. 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 Yep. Okay. Now comment out your debugging.
Debug, 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 debug.
Okay. Good.
Wow.
So you just need to speed up.
How do
You
I-
need to even speed this up. Even speed this up. How do you speed this up further?
let me just try using scanf. I don't know.
Oh yeah, can F, yeah. Are you stream lah? Are you stream first lah? You haven't, right? Or you have? Sorry, are you speed?
Oh, already.
Oh, you already, okay. Yes, you scan F then, right?
I'll
Change everything to scan F.
scanf. Scanf. How do you scanf? Oh yeah. Percentage D for integer VI address. Yeah. Print F. Print F. Where is it? Is there anything else? No. Print F. Yeah.
Yeah, after this, you're going to say. So that is valid.
The first C in.
The first C in. Oh yeah. Scan F percentage D comma
Ampersand N, yeah.
ampersand. Is that what it's called? Ampersand. Oh, that's not it. Try again.
You should erase the IS space.
Oh yeah. Okay, it works now.
As it turned out, it's always
Yeah.
it didn't actually do anything.
Well,
Yeah, how do you speed this up? Oh, your print F, is it?
how do I speed this up?
You don't need to debug anymore. You can remove all your debugging, right? You know your logic is correct. Just need to speed up now.
But I thought wrong answer can be behind Kelly. Is it possible?
That's also true, but I think it's unlikely. In
Oh.
this case, I think you got the logic solid. You just need to speed up now. What else? What are the other optimizations you can do? Okay, show me the query and update. Is there a way for you to?
We don't really need the vector, right? So we don't have to input the vector and then do the array. We can just straight away while inputting the vector, we input the array. We do what we need.
Yeah. Okay.
In car, next. C in car.
No, it's not in. Remember?
Scanf.
Oh yeah. Scan F percentage D comma ampersand current. Car max equals to car. Then we don't need this.
Car max equal to car. Oh yeah, of course.
Minus. Then for in I equals to 0, car equals to scan F. Oh wait, no, this is not really doing. Just scan F. Scan F when the current minus. Okay.
Yeah, then you remove line 39, 40, 41.
Yeah. So you don't need B. You can just remove it. E. Oh, next VI. All this should be replaced with current.
Okay, you save the vector.
Oh, I still have. I don't think it'll affect much. Ah, still in the same position.
No change, yeah. Hmm. Yeah, how do you speed up even further? How about resize? Just create the segment tree, the largest maximum number. Just make it array. Yeah. What is the maximum number of n? 2 million, I think.
2 is 6.
Yeah, 2 million.
So
So just 8 million basically.
yeah, 8 is 6 plus 2. Or 60%.
No, you don't need plus 2. Even 86 is already plenty. Yeah.
That's double. So I have to int. Oh, what?
The
No template. Oh, I still need vector. Yeah. That's
yeah, but it's actually technically doesn't have to be vector, right? Can be just array, right? Yeah.
oh yeah. Then I don't need this at all. I can just like this. I don't need vector.
Yeah. And then your main, what do you do? Your main, I think you when you build, is it?
Okay. Yeah.
Build.
I don't need. What's wrong when I use min car max?
Oh yeah, I use
Okay.
using namespace std.
Oh, I don't have. Oh, I still have that.
Min max is in what? IO stream, is it?
Is it?
Min max is included in where?
I don't think it's an IO stream.
Not in our stream.
Min max C++ include.
Algorithm.
Our
Okay, really? I didn't use algorithm.
Yeah, but okay, never mind. It's okay. Yeah, just do it.
Oh.
Yeah, it's okay. I think it's also in IO stream.
Oh, I see.
Maybe that's why. Yeah. Okay, doesn't matter.
Try.
Try.
Run all. You submit.
It's very interesting.
Well,
Oh wow, still TLE.
Oh, what we removed one.
Is it reduced? The number of TLE, is it reduced?
Yes,
Oh really, yeah.
from 38 to 40.
It is?
Yes, we reduced 36 and 37.
what is the
You know,
time complexity in this solution?
That means
ON log n.
one log n each. Yeah.
ON log n, but maybe the ON log n is not so sufficient.
Do you think it's like you need
Sorry.
only n?
I think on log n is sufficient, but it's just two. It's two on the edge, so it. Yeah, sometimes it gets out, sometimes it fits.
Okay, can we see if we can speed up update and query?
Maybe we don't need to sum up. Oh, we do need to sum up. Oh, but do we need to sum up? We just need.
You don't need, right?
Yeah, we don't need one.
It's just you just need to know whether it's non-zero or not. That's it.
So I can do like that. then return segment 3 index equals to max sec3 index times 2 sec3
Why are you changing the logic? This is not speeding up at all. How is this speeding up? It's the same.
I don't think it makes any difference.
Yeah, and you're risking making wrong, yeah, because you're changing your logic actually. You're risking
Oh,
making it wrong now.
okay. Then
So
How about the query part?
wait, yeah. Wait. What if you don't have to build? Just mem set everything to 1.
yeah,
Because you don't need the actual sum, right? You only need that it is non-zero. So you can comment your build and just change it with memset.
I don't think memsec can get 1, right? If I'm not wrong.
You can
Or 1? Yeah.
comment out build. You can just comment out. You may need it later, right? It's okay. It's okay. It's okay. It's okay. It's okay. But I don't know how much it will save though. It's just changing the initial.
Ooh,
Yeah, it doesn't save much.
No
Yeah.
difference.
we solved 1 more. Oh, but
Did it save anything?
we solved 1 test case, but we lost 2 test cases.
Okay, it's already very late night. Time to sleep.
Oh wait, but it was so
Yeah, tomorrow you got school.
no.
Habibie, are you making progress with the stack approach from the editorial?
I doesn't understand the code in the editorial.
To subtract
Like that,
by decreasing method. But it's basically the same as my brute force method.
What do you mean? Sorry, Weilian, what did you say?
If you want to solve this question, you can even use brute force to earn at least certain marks, right?
Yeah, but then
Yeah.
yes.
Only first subtask.
Even
First
if
and
you
second.
brute force, you can still get 1 subtask wrong. I mean, correct.
Yeah, first and second type subtask if optimized.
If optimized, you can also get the second one correct. That's what I did.
Yeah, so I think now the question is how do we optimize the segment 3 further so that we can get past the half second.
So the memset part is even slower than the build. I don't know.
Oh yeah, maybe you reverse, man.
Hmm?
You reverse the logic.
What do you mean?
Oh, we cannot there. You reverse the logic meaning if by default it's 0, right? So you don't do memset. By default everything is 0. So you reverse. So you treat 0 as 1 and 1 as 0. So when you update to 1.
Oh,
You update to 1.
so return. So we don't need to build. We don't need to build. You don't need to do.
Leave it. Just leave it. You're not calling it anyway. Yeah, comment out. So your return your here is instead of yes.
This is just leave it like this.
No, leave it. It's correct, right? It's still correct.
Yeah.
So
Return 0. Yeah, this correct also.
oh, this was okay. Not return 0, no, return 1, right?
Then if segment 3 index, then return 1. If n equals to r, return segment 3 index. You need.
Oh yes, correct.
Then if not.
Yeah, then.
I mean, if query is true, Oh no, okay.
You didn't memset, right?
Yeah, I did not.
Is it by default 0? It's global, right?
Yeah,
If it
it's
is global, it should be by default 0.
Yes.
Okay, query. Can we check query?
Query.
Okay, can we check? Oh, because it's plus. Your update is plus.
One thing, do you
You
think we
cannot
can
use
get
that.
the array to a bool array? Since you only need two,
You
like,
need to use minimum. You need to use minimum as instead. Minimum between the two updates. Because you want it to be, if one of it is 0, you want it to be 0. Yeah.
Oh.
Yeah, but this is only saving the memset.
Does
I
it?
don't think it will change much.
as it turned out, it didn't make a big difference.
Yeah.
Yeah, memset is fast.
Memset isn't actually quite slow. It's even faster than the vector initiate.
Okay, is there a way for us to not even use minimum here?
We could just set it as
Okay, so here, if one of it is 0, you return, right?
yeah.
So you can actually just say, if update, the first update is 0, just return. Return already 0, you know it's 0. So you don't have to call the two updates. You call one by one, and if you are lucky, you don't need to call the second one, right?
So
Yeah, if it is 0, you return 0, right? Correct?
but we still have to update, right? Right?
Yeah. If it is 0, you update to 0. And then return 0. You need to update also, yeah? You need to, yeah, correct. Yes. And then do the same thing for the second one. Yeah. This sort of, if you are lucky, you don't have to. Yeah.
Times 2.
Oh, now becomes wrong.
Return 0.
Okay, never mind. Time to flip. Undo the changes. Maybe you revert back to the memset version better, mas. Because this is very confusing. When we flip the logic, it's very confusing, right?
Oh, this is too much. Down.
Right. The easiest is you just copy paste from your submission. Do you know which submission? Okay. Okay, just stop here. Go to sleep, yeah. It's very late now. 2 hours already. Enough. Let's go.
Okay.
10:30. Continue tomorrow. See how you can optimize so that you can break the half second. And if you like, you can learn the editorial like what Habibie was trying to do. It's an ON solution. It's just using stack. But honestly, reading it is very confusing. I couldn't understand also because the text is so verbose. But yeah, something to do tomorrow. Okay, cool. Thank you, everyone. This was great.